Hey class, this week we're talking about populations. That's right, we're taking it up a biological level of organization. So up until now we've been talking a lot about organisms. We did cover populations back when we talked about evolution, but when we started to talk about ecology, we started to focus in on how organisms survive and find energy and then how they use that energy to grow and reproduce. But ultimately, when organisms are doing that, the collection of organisms doing that is a population. And because organisms in a population are reproducing, populations can grow over time. And those are the topics that we're going to start to address now. So the most immediate objective we have, however, in this lecture is to just start out by defining a population and explaining how one could accurately estimate its size. Because if we're going to think about the growth of a population or the decline of a population, we need to be able to estimate its size over time. So we'll start out with that simple goal. So what is a population? When you think about this word, hopefully what comes to mind is something like this definition here, which is the kind you would get out of a standard textbook in biology. It's a group of individuals of the same species living in a given area. Now, this seems helpful at first, but of course it raises a whole bunch of other questions, two of them being, well, if it's a group of individuals of the same species, what kind of a species are we talking about? And then previously we talked about this idea of species concepts and that we have biological species and morphological species, and some people think about evolutionary species. So if we're going to define a population, we have to at least be clear which species we're talking about. And as I said before, most of the time we as biologists are thinking about the biological species concept. So we might think about a group of interbreeding or potentially interbreeding individuals in a given area. But of course this still leaves another important question. What's a meaningful area? Would it be the number of individuals in this room? Would it be the number of individuals of a species in the United States? Would it be global? And here's where the definition starts to be sort of airy-fairy. And that meaning is that biologists kind of just apply this in whatever context they think is important at the time. So, for example, I might be talking about a population of squirrels, and I might be talking about squirrels in southern Indiana for a specific reason. And then later, in the same day, I might be talking to another biologist about a population of plants, and I might say the North American population of a certain species of plants, right? Because I want to know, maybe I want to know about the entire North American population of oak trees. In which case, you notice I've jumped from like a small area to a massive area. And then at the same time, somewhere across the hall in the same biology building, a bunch of scientists in the lab could be talking about a population of bacteria in a beaker. And so all of these applications of area are actually okay because the idea is that we're picking the appropriate area for the current conversation that we're having. Well, that leads me to throw this at you. Have a look at these four pictures. One is giant panda, and we can imagine all the giant pandas in China. And the top right picture is a bark scorpion, and they're very common here in Phoenix. So we can imagine the group being all the bark scorpions in Phoenix. The lower left picture is a photo of humans, and it's a person standing in streets in New York. So we can imagine all the humans in New York. And then finally, the bottom right shows E. coli, a bacteria, in your intestine. So you can imagine all of the E. coli in your small intestine. Now, of these four groups, which one of them is not a population? Take a minute to think about that and answer this question.